PeaksX Plus adds several exciting new features to the already powerful Peak Studio. Now, in Peak Studio, you have the ability to create spectrum libraries and perform a spectrum library search using either data-independent or data-dependent acquisition methods. Also, we further improved our de novo sequencing algorithm with the help of state-of-the-art deep learning techniques. A retention time prediction algorithm has been added to provide added confidence to de novo sequencing predictions, and a new quality control report has been added to provide further statistics about your results. And a further improvement to our label-free quantification has been added with identification-led quantification. First, let's talk about the new Spectral Library search. Using Spectral Library searches in Peaks gives you the power of the Spectral Library search workflow. Start with a library search to identify peptides found in the library, then widen your search space using PeaksDB to search the remaining spectra against the protein database. Then, make novel identifications of the remaining spectra with de novo sequencing. First, let's look at creating a spectral library with Peaks. Peaks spectral libraries contain more information than traditional spectral libraries, including retention time details and important unmatched ions. This allows for an improved accuracy and sensitivity of your spectral library searches, and PeaksDB results can be used to generate a spectral library. Any PeaksDB result can be used to generate a spectral library. Open the result in Peak Studio and set the filters at the top of the summary page. Then, go to Export, select the Spectral Library node, and click the Peaks Library option. The library will be available for any feature searches of similar data. An option is also available to generate an OpenMS library for downstream processing. Setting up a library search in Peaks is easy. Loading in the data and setting up the project is the same as previous versions. Select the instrument, enzyme used for digest, fragmentation type, and acquisition mode. Then, continue on to data refinement, then identification, and select the library search node. To set up a new library, click the View button beside the Select Library drop-down list. Then, use the Browse button to select the location of the library you would like to search. Validate and save. A variety of charts are available to see details of the spectral library to ensure it matches the data you're searching. Also, along with the usual error tolerances, new parameters have been added for the spectral library search. Set the expected peptide length, mass over charge, and expected charge ranges. Also, select a protein database for protein inference. The general options are where the added benefits of using Peaks for a spectral library search are seen. Click the Estimate FTR button to use our unique method for FTR determination specific to library search. Decoy spectra will be created in order to determine the false discovery rate. Click the Perform Database Search button to set up a PeaksDB search. By default, only spectra that don't match a library within a 1% FTR will be included in the PeaksDB search. Or, change this filter to be more or less stringent. Also, set up a de novo sequencing analysis on unmatched spectra to identify peptides missing from both the spectral library and the database. Click the Advanced Settings button to fine-tune the parameters of these searches. You're then ready to start your search. Once the search is finished, you'll get the powerful user interface tools provided by Peak Studio. In the summary view, set the FTR, PTM localization, and protein filters. If multiple samples were searched, the summary view of the PeaksDB results will contain automatically generated Venn diagrams showing the overlap of proteins across samples. Then, view the protein identifications in the Protein tab. New views have been added to the Peptide tab. Here, you can see a comparison of the library and hit from the dataset to confirm the accuracy of the result. In the Peptide tab, use the Found By column to see results matched by the library search or the PeaksDB result. The De Novo tab is where you'll find De Novo only results. These are high-quality de novo sequencing results missed by both the library search and PeaksDB. While we're talking about de novo sequencing, a powerful update has been made to the Peaks de novo sequencing algorithm. Our retention time prediction algorithm, developed using state-of-the-art deep learning techniques, gives accurate predictions of the de novo results. Here in the de novo table, you now have the predicted RT and delta RT columns. The delta RT column is an excellent tool for troubleshooting your de novo sequences. De novo results with a small delta RT are more likely to be the true peptide sequence due to the small difference between the actual RT of the result and the predicted RT. Predictions with a large delta RT are less likely to be the actual sequence. Analyzing these predictions can help you make adjustments to your parameters, like adding post-translational modifications to improve your results. Also new in Peaks X Plus, the quality control statistics give you more insight into the effect your mass spectrometry method had on your results. With a project selected, click the QC button to generate the report. The statistics page gives identification rates and details about the identified peptide features and their width. The acquisition distribution tells you how many MS2 scans were taken over time and the number of MS2 scans per cycle, while the chromatography page gives a distribution of the peak width of the peptide features detected in the LC-MS. The identification distribution gives details about the protein identification trend across samples, mass error, and scans per peptide. To further improve the accuracy of our quantification, a new quantification method has also been added to Peak Studio X Plus. You can choose between our new identification-directed quantification and the previous feature-based quantification methods in the configuration menu. Then, Label-Free Method tab. By using only identified peptide features, the accuracy of the retention time alignment, feature vector construction, and match of peptide features between runs is greatly improved. Using only identified features also significantly increases the speed of quantification. To see this improved accuracy, you could use the new statistical charts. There's a new sample correlation option. Click the sample correlation button, hold Ctrl to select multiple samples, then click OK to create correlation plots between samples. Or use the density ratio plot. This can be used to see the distribution of ratios around the mean. If multiple populations are present, you could click and specify them using this button. If they can be separated by details in the accession column, you can easily separate them. Then specify the expected ratios. Peaks also by default uses ID transfer. This applies identifications from one sample to unidentified features from other samples in the project, reducing missing values. This new figure in the summary view highlights this, showing missing values before and after ID transfer. Thanks for taking the time to check out our new features in Peaks X Plus. To try a demo, download a trial version from our website, bioinfor.com.